Today I want to talk about operator associativity. What does it mean? Why does it matter? How is it implemented? Let's start with a simple example. Here we have a simple calculation, 3 minus 2 minus 1. And it consists of three operands, 3, 2, 1, and two operators, minus and another minus. And each operand belongs to exactly one operator. So we can ask the question, does the 2 belong to the first minus or does it belong to the second minus? Or in other words, will the first minus be evaluated first or the second minus be evaluated first? Maybe it's a little more clear, the distinction with additional parentheses. So here you can see if we first evaluate 3 minus 2 and then minus 1, we will get 0 as a result. And if we say 3 minus the result of 2 minus 1, we will get 2 as a result. So those are different results. So it's important to say, do we mean this interpretation or this interpretation when we don't see the parentheses? And we call this first behavior left-associative because the left minus is evaluated first. And that's what mathematicians decided upon. This is the correct interpretation. Okay, here's a second example, 2 to the power of 2 to the power of 3. Again, depending on whether you say I want to evaluate this guy first or this guy first, you either get 64 or 256. And in this case, the second interpretation is the one that mathematicians decided upon. Hey, let's say exponentiation is right-associative. So whenever you see a sequence of these operators, you have to basically start from the right and then work your way to the left. Okay. Here's a third, more interesting example. This time it's a Boolean operator. So A or B or C. Again, we can ask the question, does the B belong to the first or does it belong to the second or in other words, will this guy be evaluated first or will this guy be evaluated first? Right? So you will get these two formulas if you insert explicit parentheses. Okay, if you try this out with all possible combinations of A, B, and C, there should be 8 possible combinations, if each one can be true or false, you will see that every time you get the exact same result, right? So just like plus or times, it doesn't really matter if you calculate from left to right or from right to left. It doesn't make a difference. I used to think that short-circuiting made a difference. I used to think, if A is true, I don't really need to look at the rest of the formula, so this looks more natural to me. But you can try it out yourself. So if A is true, then we won't look at B, then this whole guy will be true, and then we won't look at C. So in both cases, if A is true, you won't look at neither B or C. So it really doesn't matter. Still, I find this, for some reason, more intuitive. Okay. And as we will discuss next, from an implementation standpoint, the difference of left-associative versus right-associative is implemented via loops for left-associative and recursion for right-associative operators. Let's look at that next. So here's the implementation of Carroll's condition parser. The interesting functions are disjunction and conjunction. So disjunction parses conditions like A or B or C or D, etc. Whereas conjunction parses conditions like A and B and C and D, etc. Okay, so let's focus on the disjunction function first. I prepared a example which we are going to step through. So we want to parse this expression or this condition. Left is clear or front is clear or right is clear. It's a very simple example that doesn't involve any conjunctions. So that makes things a little easier. And all we are interested in really is, will this be parsed as left is clear or front is clear or right is clear? Or will it be parsed as these guys in parents and then left is clear combined with that? Right? Okay, so let's see. Let's simply set a breakpoint and let's see what happens if we run my little prepared test. So let's see the first conjunction. So we start at the beginning of the condition and want to parse the first conjunction, which will simply be left is clear because there are no ampersands after that. Okay, left is clear. That's our first operand for the disjunction, basically. Now we check to see if there is indeed a OR operator. There is. Let's accept it. And now temp is our first operand, and the second operand, we don't know what it is yet, right? We have to call ourselves recursively. So whenever a function calls itself recursively, you can see it here, IntelliJ IDEA highlights it for us. If you do this at runtime, on the call stack, another activation of the function will appear. Let's see if we step into the function. Here you can see here's the second activation. Okay, now we pass the next conjunction, which should be front is clear. There we go. Then we see the next OR operator, which we then accept. And now we have to step into the disjunction function yet again, because we don't know what the right operand is supposed to be. Right? We know the left operand is front is clear, but we don't know the right operand yet. So let's step into the function yet another time. Next conjunction is right is clear. There we go. There are no more vertical bars, so now we know the result of the third invocation of disjunction is simply right is clear. Okay, so let's return that one to the caller. So we know this result is basically right is clear. There we go. So now we know temp is our first operand, front is clear. And our second operand is right is clear. And those two guys will now be combined, right? So front is clear or right is clear will be combined first. Okay, let's do it. There we go. And now we can return front is clear or right is clear to the first invocation of disjunction. So front is clear or right is clear is now the result of this function call. Here you can see it, front is clear or right is clear. And that guy is now combined with the very first operand, which was left is clear. So temp should then be, as you can see, left is clear or front is clear or right is clear. You can't really see the parents very good because of the weird color scheme. Here you can see it a little better, right? So front is clear or right is clear was combined first, and then left is clear was combined with that. So that's the recursive nature of right associativity. So you want to combine two operands, but the second operand has to be evaluated first, and that will already create some syntax nodes, or will use the OR operator. So the OR operators will be consumed, if you will, from right to left. Okay, so what do we have to change to make this left associative? I already said at the beginning, instead of recursion, we should use loops. So let's simply replace the if with a while. And then we don't call ourselves recursively. Instead, we call the same function that was used to pass the first operand. So the next operand should be passed the same as the first operand. So conjunction. Okay. And let's see if we now step through this guy one by one, if we observe any differences. Okay, so we start out again with left is clear. We detect the vertical bars, okay, which we then accept. And now we only pass a conjunction. So before we passed basically all the rest of the condition. And now we will only pass front is clear. There you can see it, front is clear, right? Okay, and now we immediately combine left is clear with front is clear. Okay, so the first OR that we evaluate or construct in a syntax tree will now be this one. Okay, so now we have left is clear or front is clear. We see another vertical bar, so let's go into the loop one more time. Let's accept the vertical bars. Now we have to pass the next conjunction, which will be right is clear. And now that right is clear will be combined with the already existing left is clear or front is clear, which will give us left is clear or front and clear in parents, or right is clear. Okay, so that's exactly the behavior you would expect from a while loop. Now it's left associative. Okay, so to wrap this up, let's contrast both solutions. So most operators will probably be left associative in your simple examples when you do plus, minus, times, divides, and so on. So most of the times you will see simple while loops. Pass the first operand while you see the operator that you're responsible for passing, pass the next operand, and then do something with it, right? You can immediately calculate the result or create some syntax tree nodes, depends on the complexity of your application. So when you see a while loop like this, you know, left associativity. Okay, when you need a right associative operator, for example, exponentiation, instead of a while loop, you will see an if condition, and inside the if condition, you will see that there is a recursive call. Right? So the first operand is passed differently than the second operand. The second operand will be passed via recursion, and the recursive nature will basically apply the operands from right to left instead of left to right. Okay, that's basically all I have for you. That was how do I implement left associative operators via loops versus right associative operators via recursion. Thanks.